everyone. It is my absolute pleasure and honor to kick off the Matter Forum with a fireside chat with Sir Kostya Novoselov, the Nobel laureate in graphene and also professor at Center for Advanced in 2D Materials at National University of Singapore. Kostya, welcome. I know it is late for you.
No, it's a pleasure. It's definitely worthwhile waiting for.
Absolutely. Thank you so much for being a part of this conversation. One of the things that has always been very interesting to me personally is this philosophical and existential role of materials in shaping human trajectory. If we look closely, really, the history of humankind is marked by the ages of human mastery of materials. So when you think about the Bronze Age, the Iron Age, the age of steel, and the age of aluminum that's enabled these commercial air travel, age of silicon that's enabled this digital modern era that we live in. So my question for you is this: after almost 2 decades of pioneering work in graphene and 2D materials, how do you envision the future in which we have mastered 2D materials? What's the shape of that future?
Well, first of all, I think that the way we treat and call our ages the names of materials, it just shows how limited we are in our ability to create something new, and that's really I think it's, if not disaster, it definitely shows the limitations of our ingenuity and of our imagination. And in that respect, the progress which we've seen over the last century at least, and probably even over the last few decades in terms of material development is really fantastic. So we're moving towards composite materials, nanostructured materials, where we can implement new functionalities, not only properties. And for me, functionalities and properties are slightly different matter, and that shows that material science start to be a real science rather than art and craft. And that's what I think we need to sustain for the future. Because if you think about this, that's even such technologies which are supposed to be well developed, like oil refinery, like many of the chemical production, it's still a lot, up to a large extent, is a craft, and really depends on the knowledge of a few individuals, on their feeling of the process, which is great. As a scientist, I really appreciate it. But at the end, I mean, as an experimentalist, I really appreciate it, and I like sometimes to call what we're doing really a craft, a magic. But at the end of the day, we need material science to be real science, and when it starts to be predictive, fully predictive, that's when we can start enjoying this. And having this ability to create materials with predictive properties, with the properties which we can anticipate much in advance rather than working with what we're given, is exactly the future of material science, I think.
That's quite an interesting take on that. And I know that you have been talking a lot about smart materials and intelligent materials, and that systems that we create with the predictability of these systems is going to be defining what we do with them in the future. Do you have any examples of what that shape of the future with these intelligent and smart materials systems, predictive systems, are going to look like?
Of course, many of us who've been working with graphene, with the two-dimensional materials, really enjoyed the opportunities which are given to us by the 2D crystals, which you can use as building blocks to combine and create van der Waals heterostructures. So you create artificial 3D materials with the on-demand properties. So people call it band structure engineering, people call it material engineering, designer material, and that really 2D materials really gave us a lot of knobs to create on-demand materials. And of course, the recent examples, the breakthrough happened a couple of years ago. Pablo Giulio Herrera led the discovery of the flat bands in twisted bilayer graphene. Really shows the power of this method. So that really gives the next step in the material engineering story. But of course, what we really want is to make even further, is that we can try to create materials which are not only have the designer properties, but also which are adaptive internally, and that would be something very new. So in that respect, we are now trying to create combinations of materials which are interactive, which are interacting through many different channels to create metastable states internally, and then by controlling the jumps between those metastable states, we can give memory to the material. Like if you think about this, like protein folding, which is a very famous example, of course, and the reason why proteins have so many functionalities is exactly because they have so many metastable states, and you can control the particular state by moving from one metastable state to another. So similarly, we are trying to create artificial materials with such properties, and we have some success in it. So we are moving from the designer material with the designer properties to designer functionalities. So they have certain intelligence built inside them.
That's quite an interesting prospect for the future of what these materials can do. And I wanted to ask another question of you, and perhaps it is aligned with what we were just discussing, but a little bit more on a different side. We often talk about science for the sake of science, and then science for the sake of commercialization application. In a forum like this, we're talking about science for the sake of societal impact. As ingredients to the architecture of tomorrow, with the power to really change, with some of the examples you just gave us, technologies that can radically change the way that we look at the future. Do you personally think that there is a role and responsibility for frontier material scientists? Is there an ethical mandate for them to think beyond the novelty and exploration of science and actually focus primarily on impact, or should we have freedom of exploration and leave it at that and not think about the kind of impact that it can have?
This is really good question, and frankly, I don't have a ready answer to it, but I have an opinion on it. And my opinion is that, I mean, science, and again, people know me, I'm a scientist, and I'm completely rational in many aspects, and I know that if my device doesn't work, it means that someone forgot to solder a wire somewhere, or just applied to high voltage and burned it. But sometimes I have a feeling that science is still developing in parallel to us, and just nature gives us certain opportunities for discoveries, but those discoveries, they're not 100% depend on us, and those discoveries do happen at certain period of the development of humanity, and that only partially depend on our efforts, and partially depend just on on the historical developments, and then and it just given to us by the nature. So so in this respect, I would say we need to try to develop science and study nature as much as we can, and it is impossible to forgive and ring fence certain area of science and say, okay, we shouldn't go there. You cannot do it with human brains. You cannot just ring fence some areas and forbid people to study this, or just say that certain areas are definitely much more interesting and we should apply all our efforts to do that. Science is developing partly even beyond us, even aside of us. So, but then having said that, technology, which accompany science quite closely. I don't put equal sign in between them, but the two go quite often hand in hand. Can be targeted and can be directed, and of course, technology helps science as well, as same way as science helps technology. So we can affect science in certain respect, but also what I want to say is that the surprises which are given to us by science very often supersedes the most wild imaginations. So we can of course try to push science and technology into certain directions, but from my experience, the surprises which were given by nature in our scientific research supersede any of our hopes. So, is there any point in trying to direct research? Well, I don't into certain areas. I'm not sure. I'm actually very much a supporter of the blue sky research, which brings surprises and brings the quantum leap in our knowledge and in our technologies.
That's a great point and opinion in this matter, and I want to kind of get a little bit more on that. Ask you another follow-up question, which is, we hear a lot of graphene or other materials, or frontier materials, nanomaterials, low-dimensional materials, looking for a problem to solve, and which is a absolutely valid point. And that is a problem, and it sometimes leads into maybe not as much of as impactful solutions or innovations. But at the same time, is it the role of the scientist? Is it fair to put that responsibility of analyzing, knowing, and conjecturing what the real pressing problems in the world are on the shoulders of the scientists, material scientists, to go and figure it out? Or instead, we should allow for that exploration and innovation and discovery, but be able to create channels and initiatives that allows us to connect the world of problems with the world of exploration and science, so that the problems come to the scientists, not just from industry, but also from civil societies and other layers. So it's not on the shoulders of the scientists necessarily.
Oh, first of all, I think that it would be very unfair to put all the responsibilities on the scientists. So scientists are only responsible to translate the truth from nature to the general public. That's all what we can do. We're simple interpreters on what nature tells us, and we just translate it in a language which can be understood by general public. And in this respect, we only, I mean, a translator is not responsible for whatever a politician is saying. Same is with scientists. But scientists are, of course, responsible in bringing this knowledge to the general public, because we are often much better equipped in understanding the boundary conditions, what is fundamentally possible, what is fundamentally impossible. And of course, we can be wrong from time to time. And of course, the recent pandemics demonstrated how poor, I mean, even the most basic mathematical models, the model of the epidemics is probably something which we all study in math class, in computer modeling classes, in school and universities. And when we come to the real pandemics, we are quite hopeless in this, unfortunately. So, but at least we understand the boundary conditions and what is possible, what is not, and that's exactly is our responsibility to translate this to the general public and explain the limitations of our modern technology, the limitations of our scientific knowledge, and try to persuade people that we need to know more. It's our responsibility to know more.
That's quite an interesting point that you bring, a science as translator, and that not being the responsibility of the scientist, but the responsibility of us as a community to create those channels which connects those elements, the problems, bring them to the scientists. They have the tools. It's not their responsibility to go out there and know exactly what are the real problems in the world, or what are the most pressing problems for the environment, for the health, etc., etc. We need to be creating that channels with civil societies, UN Sustainable Development Goal networks, etc., etc., to be able to connect those. And with that, I want to ask you another question, which is, which problems in our world right now currently most concern you personally?
Well, I think the fact that we don't have a complete solution in terms of energy consumption, and as part of it as food consumption. That would be that's probably one of the burning problem, and it has many aspects in terms of the greenhouse gas emission, in terms of overpopulation. But at the end of the day, it's all about energy resources. And I think material science is exactly at the forefront of finding the solution here. It's both in terms of being more economical, in terms of recycling, providing new ways of generation of energy, and also in terms of food production as well.
That's an interesting point, and a very, very good point for us to end this conversation with. But before I let you go, I have another question for you. And I'm going to not put any limitations or boundaries on it. I'm just going to ask the question. If you had a magic wand and you could make anything happen, what would you like to see happen?
Well, Zina, you know, if you give me a magic wand, that's it. That's my life is done. So I can if I know that the magic wand exists, that's all I can hope for. So if you tell me just one word, if God exists or not, yes or no, I take either answer. I would be absolutely happy. So my curiosity would be satisfied forever, and I'm prepared to die the next moment. So if you satisfy my curiosity with telling me that magic won't exist, that's it. So I'm satisfied for the rest of my life.
You know, Kostya, I would have expected any answer but that one. So you absolutely surprised me. It's been an absolute pleasure and honor to have you here and have this conversation with you. I appreciate your time. And I would like to invite everyone else to, if you have any questions for Kostya, you can actually send them in the chat, and we will see you in about 10 minutes. We are going to be taking a break. You can sit around the tables and discuss the topics of this panel and Fireside Chat. Thank you all. We're taking a break now.
It's a pleasure, Zina. Thank you.
Thank you.